As we look into section 2.2, we're going to continue looking at graphs and displays. And the first thing we're going to look at is what is known as a stem and leaf plot. And it looks similar to a histogram in the way it organizes data. Um, but let's just look at it by example. A stem and leaf plot has two components. It has a stem and a leaf. And what it does is it uses part of a number um, in one column called the stem. If it's a two-digit number, it's typically the tens digits. So notice we have numbers in the 40s all the way up to the 90s. So let's put tens values of 40s, 50s, 60s, 70s, 80s, and 90s. And then the leaf, or the leaves, each piece of data will be represented with its own leaf. A leaf typically is a single unit. So here, in this case, it's going to be the ones place. So the number 47 has a leaf of 7. The number 62 has a stem of 6, a leaf of 2. 71 has a stem of 7, a leaf of 1. Then you have 83, 91, 65, 72, 79, 85, 89. That takes care of the first row. Then we have 88, 76, 74, 93, 91, 66, 76, 87, 91, and 89. Now, once we organize our data into a stem and leaves, then we typically put those in order from smallest to largest. The first one, that's easy enough. It has one data value, just 47. In the next row, there are no 50 values. And then in the next row, we have a 62, then a 65, then a 66. Those are already in order. But if we look at the next row for the sevens, we have a 1, we have a 2, we have a 4, we have two sixes, and then we have a 9. Notice how quickly that was to put those in order. The next row we have a 3, a 5, a 7, an 8, and then we have two 9s. The last row we have 1, 2, 3 1s, and then we have a 3. Notice in our stem and leaf display that has completely put our data in order from smallest to largest. We have 47, 62, 65, 66, 71, 72, 74, and so forth. It's similar to a histogram in that each row is kind of like a bar. It allows us to visually see which categories we have the most values in. Notice there are none in the 50s, only one in the 40s. Most of our data is in the 70s and 80s. We'll be talking about mode in the future. Remember, the mode is the object that occurs the most. Notice attached to this stem, we have a 1 3 different times. In the future, we'll be needing to have numbers in values in order from least to greatest, and it'll help us to find different locations in our data. We'll talk more about that in the future, but the stem and leaf display quickly helps us to put those in order. Now, one thing that I like that this book does is it has a key. Usually somewhere it'll say for this 7 equals 47. It could be that all of these were decimals, and if all of these were decimal values, then instead of this standing for 47, it could have been that that stood for 0.47, where the stem was in the 10th place and the leaf was in the 100th place. So this just helps us know immediately what quantity number. Are these simply just integers? Are these decimals? If they're decimals, what position is each stem in, and then the subsequent leaf. Now, occasionally when we have excessively large sets of data, we might break each row into 2 rows. So we might have 2 rows of 2 rows for the 50s, 2 for the 60s, the 70s, 80s, and 90s. The first row will be numbers 0 through 4, and then the next row will be numbers 5 through 9. So 47, it would not occur there. But the 5 and the 6 would be here. For the 70s, we'd have 1, 2, and 4 in the first row, but we would have 6 in the second row. For the 80s, we have 3, 7, 8, 9, 9, and then the 90s. So this simply takes each, if we wanted to consider them classes, over here, a class is 10 units wide, but this allows us to cut those classes in half. So this class goes from 40 to 44, 45, 50 to 54, 9. Sometimes that gives us a even clearer picture of the distribution of our data values. So those are stem and leaf displays. It just helps us organize our data. Oops. Another display that we use for quantitative data is the dot plot. And the dot plot is similar to a histogram. It's another instrument to display frequency distributions. And on a dot plot, there's a dot for every piece of data. Each data entry has a dot. If we look at this example here, this data goes from 21 up to 45. Notice we have each number from 21 up to 45 listed. And each piece of data, we have a dot. So 21, we have a dot here. 25, we have a dot. Notice we have another 25, so that has a second dot. So we can see the value 25 is repeated. The value 36 is repeated. Each of those values occur twice. 26 occurs once, 27, 28, 30, 45, all of those occur one time, but these each occur twice. If one of these pieces of data occurred an additional time, let's say we had another 25, then we'd have another dot up here. So instead of using bars, we just use individual dots, and that helps us to see how our numbers are spread out. Most of our data occurs in this window that goes from 25 up to 30, with in this set of data, 25 and 36 occur most often. So we can quickly draw some analysis on our data just from looking at that plot. We can also do graphs dealing with qualitative data. The most popular one probably is the pie chart. Um, if you think about pieces on a pie chart, those usually represent different categories. Categories are used with qualitative data, qualities. So on this, we would have a circle, and then we would have a slice of that circle for each category. Now, the great thing about tools like Excel is that Excel will let us put that data in, and it will generate a pie chart for us very quickly. But if we're having to do this by hand and we're having to use a compass and protractors, we need to know, for example, what angle each section is represented by. We know that in a complete circle, there are 360 degrees all the way around. We could convert this table into relative frequencies if we add those together. Pull out my calculator. If we take 1003 plus 1870 plus 754 plus 178, 3,805 people are being dealt with in this survey. The first one, we have 1,003 out of all of those. So 1,003 out of the 3,805, not 3,905. So that's roughly 26%. The next one is 1,870 out of a total of 3,805. So almost 50%, 0.49. Then we have 754 out of the total. So that's, let's call that 20% or 0.20. Remember, anytime we're calculating a percent or a decimal, it's the part divided by the whole. So lastly, 178 divided by 3,805. So about 0.05. If we add those up, that should total 1, or 100%. So these are the relative frequencies, and we can convert those into angles on our pie. Let me erase a little bit over here. So for this first one, we want 26% of 360. 26% of 360. So of means multiply. So we take our percent in decimal form times 360. Oh, wrong button, David. 0.26 times 360, 93.6 degrees. Then we want 49% of 360. So 0.49 times 360, 176.4 degrees. Then we want 20% of 360. That gives us 72 degrees. And then 5% of 360 gives us 18 degrees. So if we were to draw our circle, our pie, and let's do that. That allows us to know what angle we should have for each. So one of those was almost 180 degrees. So that would be half of the pie. So bachelor's degree would make up that one. So we could say that half of this, not quite half really, but almost half, is a bachelor's degree. And then if we go, then the next largest one is associates. It's a little bit over 90 degrees. So if we come off and a little bit over 90 degrees, there's associates. And then masters is 72 degrees. So maybe something like that. And then the last category, which is almost 18 degrees, is a doctorate. So the doctorate degree. So that allows us to make our pie chart. So we determine our angles that correlated to each of our categories. So that's our pie chart. Another chart that we use for qualitative data is known as a Pareto chart or a Pareto diagram. And Pareto charts use the relative frequencies, sometimes the frequencies, but the horizontal axis are categories. Each category has its own bar. Notice there are gaps between them because the bars are categories. They're not classes from one number to the next and from that number to the next. They're just different categories. And again, like I said, they're in decreasing height. So this is the largest category, and then this one is the smallest category. So here's an example. Top 5 causes of death in the United States. We can quickly look at it and see that this first category is the largest. That's heart disease. The next one is cancer. Then chronic lower respiratory disease and so forth. And by having this diagram, we can make comparisons. You might notice that the third through fifth leading causes of death, if we added those together, it still wouldn't equal what the number of deaths from heart disease or the number of deaths by cancer. Or we could compare that these two have roughly the same number of deaths annually. So it's just a visualization to help us compare our qualitative data. Another type of graph, it's called paired data sets. Is kind of a strange way to say it, but it's just when we have an ordered pair. When we have points that have two variables that are both quantities, then we can make it's called a scatter plot. And a scatter plot is just what we normally think of as a regular graph, where each point has an x and a y value. So we have one variable in the x. It could be somebody's height, it could be weight, it could be time, and then we have another variable in the y direction. So we can make a scatter plot. Here's some data from a famous study that compares the petal length to the petal width for irises. And if you make an ordered pair, each ordered pair is going to represent one piece of data. But that piece of data has two components. It tells the length of the petal and the width. So if each flower measured has a dot for it, plot those the way we normally plot points, and we can notice a trend that in general, as the petal is longer, then it is also wider, which is what you may have expected. This book uses, they call this particular graph a time series, and all they mean is a scatter diagram where the horizontal component is time. It could be in minutes, it could be in years, it could be in seconds, and then some corresponding value. So if this was looking at a stock market, the horizontal component might be years, and then this might be the value of the stock at each different year. If we were looking at an object falling off the top of a roof, dropping off of a building, it might be the object's height at different times in seconds. Those are still just scatter diagrams, but since the horizontal component is a time, they call it a time series. But it's the same type of deal. So these are just different types of graphs that we can use, and depending on whether we have qualities or whether we have quantities, whether we have this is a single variable we're measuring here. These might have been test scores, so we were taking the test score from each person as compared to our time series, which was two variables. It was a time and a quantity. So these are just tools that we can use to help further organize our data once we have collected it, and now we can use those pictures to help us further analyze different trends and so forth.